exponential graphs. The standard form for writing or standard way of writing an equation of an exponential is y equals a, so just a number, to the power of x. That can be compared to, say, y equals mx plus c. Okay, that was the standard form for a straight line. Or say y equals a bracket x plus h squared plus v. What's that the standard form for? Parabola. So now we're looking at y equals a to the power x. For my first example, I'm going to make a equal to 2. Okay, and over here I'm going to draw the curve, and over here I'm going to draw a table with some different x values. I'll choose the same 5 x values as I've always choose. What are the same 5 that I always choose? You guys got it. -2, -1, 0, 1, and 2. And I'll start with 0. I'm going to put 0 into the x value. When I do that, I get 2 to the power 0. What is any number to the power 0?
0.
I always catch one person. The answer's 1. If you don't believe me, get a graphics or get a calculator, go 50,000,001 to the power 0, and you'll get 1. Choose any number you like, put it to the power 0, it'll always give you 1. So I'm going to go ahead and plot that point on my graph. When x is equal to 0, y is equal to 1. Now that is a standard feature for the exponential graph. It always cuts the y-axis at 1. The exponential graph, you always see the y-intercept, or the graph cut at y equals 1. Now I'm going to make x equal to 1. Okay, substituting 1 into the equation. What's 2 to the power 1? It's not a trick question. 2, thank you. So when x is 1 over here, we have y equal to 2. That's going to be on the equation, that plot there. What about when x is equal to 2? Answer? Great. 4, when x is 2, y is going to be 4. You can kind of see why we call it exponential, because it's going to grow quite quickly. When x is equal to 3, I'll do 3 as well. 3, what's 2 times 2 times 2? 8. 8. Because like 2 to the power 3 is 2 times 2 times 2. 3 times 2 times 2 is 4 times 2 again is 8. So at 3, my graph's not even big enough for it. It would be way up there. And you can see at 4 it's going to be 16. At 5 it's 32. At 6 it's 64. You with me? It gets bigger very, very quickly, and hence exponential growth, because it grows fast. If a business grows exponentially and you're the owner, you're very, very happy. Doesn't often happen. Okay, that's the positive values of x. Now if I consider negative values of x, let's start with -1. 2 to the power -1, answer? Half, thank you. Well done, whoever said that. Just, if some people are scratching their head, how did they work that out so fast? It's not that, there's a trick, okay? 2 to the power negative 1 is the same thing as, remember, 1 over 2 to the power positive 1, hence a half. And if I do this one quickly, 2 to the power negative 2 is the same as 1 over 2 to the power positive 2, which is the same as a quarter. If you weren't sure on how I just did that, you could use the calculator. It's fine. But at negative 1, we have a half. At negative 2, we have a quarter. At negative 3, what do you think we're going to have? Close. Not 1/6, but 1/8. You're guessing. At negative 4, we're going to have 1/16. At negative 5, not Jason, who else? Negative 5, we're going to have, sorry? 1/32. And someone on this side of the room, at negative 6, we have 1/64. Well done. Notice, the more negative I get, I'll never, ever, ever touch the, what axis? X or Y? X. It'll never touch. Anyone know the word given for a line that never ever approaches another line but never ever touches it? Not parallel. Starts with A. S. S. Now I've got to think how you spell it. A. No. S. Asymptote. An asymptote is when a line gets closer and closer either to an x-axis or a y-axis or even a number, but never ever touches it. So when you're drawing your graphs, I don't want to see your exponential come down, cut at y, and then stop there. I want it to get closer and closer to the x-axis, but never ever touch it. So be very, very particular about how you draw your asymptotes. Okay, so that was the most basic exponential. Now, let's just check it on a graphing software. I'll just start a new. Don't save that. Okay, so if I type in y equals 2 to the power x, you can't even see where that's getting typed into, but enter, get rid of that. Okay, I'll move it along so you can see it. I'll zoom in so you can see if it is an asymptote. If I zoom in and zoom in, zoom in, notice I can keep zooming in here. It'll never ever touch, right? It'll just get closer and closer but never ever touch. Zoom out. Okay, and then just check. It always cuts at 0, 1 and 1, 2 and then 2, 4 and then 3, 8, then 4, 16, then 5, 32, 6. You getting it? It's doubling. Okay, check this one out. Instead of 2, whoops, wrong pen. Instead of 2, I'm going to use the number half. Y equals half to the power x. Any predictions? Now, let's just clear this up. Does a curve have a gradient? And it's not you that I've seen other people try and draw gradients or talk about gradients with curves. Does a curve have a gradient? At year 11, no it doesn't. In year 13 calculus, yes it does. The gradient on a curve is always changing. Can you picture that? At any point on a curve, it's a different gradient. So you talk about that when we do calculus, but that's not for... In fact, you might touch it next year, but anyway. Y to the power half x, right? Same method, I'm going to choose 5 values of x. They always are -2, 1, -1, 0, 1 and 2. And I'm going to get a little bit clever and use my graphics calculator because I've got one, so why not use it? If I go to menu, table, type in that equation, y equals 0.5 to the power x, like that. Hit execute, and then go up to set. See where it says set, F5. Start at -2. In fact, I'll just say start at -3. And end at +3. I'll do a few more numbers since I've got a graphics calculator. And step up in step size 1. Hit execute and hit table. That's actually the calculations there. 8, 4, 2, 1, 0.5, 0.25, 0.125. So that saved me probably a minute. But, okay, if I can remember that, at -3, no, at -2 it's 4, 2, 1, 4, 2, 1, 0.5, 0.25. 4, 2, 1. So it goes 4, 2, 1, 0.25, thanks. Thank you. Okay, 0.5 that is, and 0.25. Plotting those values, at x equals -2, here's -2, we have +4. At x equals -1, we have +2. At x equals 0, we're going through the famous +1. Right, that was x equal to 0. At x equal to 1, there's x equal to 1. You get 0.5. At x equals 2, 0.25. Did I say something wrong? No? Internal inside joke, was it? Okay. Oh, sorry. From here we can join our dots. Okay, and that's our y equals half to the power x. Did anyone else get that?
I got 1 over 2 for 1. Is that right?
If I just quickly flick between the two graphs, watching. Right? That one compared to